Hello and welcome back to part 2 of transformations of logarithmic functions. This time we're going to take a look at how to find the equation when the graph is given. So here is the example I chose. We have the graph of some logarithmic function. The parent function is y equals log with base 2 of x, and we'll find its equation, which means that we need to find an equation of the form y equals a log with base 2 of k x minus d plus c. So we need to find all the missing coefficients a, k, d, and c. There are different ways to finding the equation from the graph. Here is my interpretation of it, and before I get started, I want to go over a very important concept. Remember that when we graphed exponential functions, we said that an exponential function, the graph of an exponential function, can be interpreted by multiple equations. For example, if we have the function y equals 4 to the power of x, this will be a parent function with a base 4. But if we have a function y equals 2 to the power of 2x, that would be the parent function 2 to the power of x, compressed horizontally by a factor of 2. However, both these two functions will be described by the same graph, and that's due to the fact that 4 to the power of x equals 2 to the power of 2x. The same thing or a similar thing will happen with logarithmic functions due to the connection that they have together. So when we find the equation of a logarithmic function, we're not just finding the equation, we are finding an equation, I would say. So let's get started with finding the actual equation. I always like to start from the vertical asymptote. I know that the vertical asymptote in the parent function will be at x equals 0. In this case, the vertical asymptote is at x equals negative 1. The vertical asymptote has moved 1 unit to the left. That tells me that the horizontal translation will be 1 to the left. And that tells me again that the coefficient d must be negative 1. So I'll write down this here. The next thing that I look at is an important point. So the x-intercept of the parent function, where did it go? Remember that the x-intercept of the parent is at 1, 0. If the vertical asymptote has moved 1 unit to the left, the x-intercept must have moved 1 to the left. So I'm going to move 1 unit to the left, and then I'm going to go all the way down until I hit a point whose coordinates are easy to identify. And the point I see here is x equals 0, y equals negative 5. So in a way, that tells me that the graph of this function must have moved 1 unit to the left, which is confirmed by the vertical asymptote as well, or the horizontal translation. And since the x-intercept has moved from y equals 0 to y equals negative 5, then the vertical translation must have been 5 units down. The next thing that I want to look at is the behavior. What I do see here is the fact that this function in here is going down. The parent function is an increasing function, whereas this is decreasing. So it seems that here we have a reflection about the horizontal axis, which tells me that the coefficient a must be a negative number. Then I'm going to look into coefficients a and k. And for this, I'm going to ask for help the x-intercept of the parent, which is at 1, 0, which must have been transformed according to the formula x over k plus d, ay plus c. So the x-coordinate, which was at 1, must have been divided by k, and then add a horizontal translation of negative 1. And according to this point here, 0, negative 5, then the x-intercept has gone down to x equals 0, so it has a value of 0. So therefore, we're going to say that 1 over k plus negative 1 is 0, which tells me again that 1 equals 1 over k, which makes k equal to 1. Just simply solve the equation by cross multiplication. And now we have the value of k. We're happy with it. And we're going to check for the coefficient a. Now, we're going to try to find the coefficient a from here. If not possible, then we can think for other ways, think of other ways to get a. But I would say that the coefficient a must have been multiplied by 0 and add the vertical translation of -5. And the point that I'm using here is actually the 0, -5. So this point won't take me anywhere, so it won't help me find the coefficient a. So the reason why is because I get 0a equals 5, so I can't find a this way. So I'm thinking, since I know the coefficients k, which is 1, d and c, then I can rewrite the equation with all the coefficients I already have. So we have a log with base 2, k is 1, so x minus -1, that's x plus 1. And then the vertical translation is 5 down. And I'm going to use another point on the graph, substitute it into the equation, and solve for a. Another point that I can identify here, or I can easily identify the coordinates of, is this point in here. I'm going to call this the point B. Let's call this A. And point B will have the coordinates x equals 3, y equals -6. So with an x of 3 and y at -6, I will revisit the function again, and I will search for a. So here we have 3. Oops. 3 plus 1 minus 5. Let's check and see what happens here. We have -6 equals a log with base 2 of number 4 minus 5. Now take -5 to the other side, and then we'll have -6 plus 5, that's -1 equals a log with base 2 of number 4. So the coefficient a equals -1 divided by log with base 2 of 4. You haven't learned how to solve this yet, or how to evaluate these kind of numbers, because we're going to learn them in the next lesson or so. But what happens in here is that this number would equal, log with base 2 of 4 would equal 2, because we use what we call the change of base formula, which is log of 4 divided by log of 2. So we give a base of 10. So -1 over 2 will be the coefficient a. So we have y equals -1 over 2 log with base 2 of x plus 1 minus 5. That would be the equation of this particular function. Now let's take a look at the features that we need to describe in here. I'm going to say domain is any real number x, x bigger than -1, range is any real number y, vertical asymptote is at -1. We have an x-intercept very, very close to -1. I'm going to call this -0.999. A y-intercept at -5. This function is never increasing, so no intervals of increase. It's decreasing throughout its domain, so for all the x values starting from -1 to infinity. About the end behaviors, we'll say that x is approaching infinity on this end of the graph, and y is approaching -infinity because it keeps on decreasing. The other end of the graph, we have x approaching -1 from the right side of it, so -1 plus. And the y values are approaching infinity in this case. So this is the lesson about transformations of logarithmic functions. And I hope everything made sense, and I hope that you enjoyed the lesson. Give it a thumbs up if you like it, and ask me any questions in the comments. I'll be very happy to answer. Thanks so much for listening to me, and I hope that you're enjoying the lessons. Bye for now.